Good morning and welcome to yet another video. In today's video we are going to see how to build a basic Wi-Fi scanner. For this we are going to use ESP dev board. We are going to today we'll be using a 38 pin board and a USB cable along with a computer. You can use any computer, you can use your laptop also for this one. So these are the three basic hardware requirements for this project. We are not going to use any display, neither we are going to use any other sensor boards or anything. So we are just going to use the Wi-Fi enabled ESP32 board, and that's it. From a software requirement, we will be using Arduino IDE and no special drivers. We will be using out of the box whatever it comes with the Arduino IDE. Just we need to see that we need to install the dev board. If it is your first project using ESP32, then you may need to install the dev board in the Arduino IDE and the few libraries. So for that you can watch my other video where I have shown how to do that. In case you have any doubt or any clarification required on that point, so you can do ask me on the comments. Before further delay, let's head into the system and see what are the different steps that we need to take to build this Wi-Fi scanner. One more point on this to add is that this is the first video on the series. Further down the line we will be building few other videos where we'll try to enhance this one and add some more external components and make it more user friendly and more professional project. So for this first video it will be a very basic video, so it gets into you and you are easy to set it up at the first go. So for today the only connections that you need to do is disconnect this dev board with the USB connector, USB wire, and the other end you need to just add it to the laptop or the computer that you are using. So once this is done, then we will hit into the system and open the Arduino IDE. And if you have not installed the dev board, you need to install the dev board and the libraries as mentioned earlier, and then proceed with the actual code. So also you need to note that in this case since we are not using any external display, neither OLED nor any LCD displays, so we will be displaying all the data on the serial monitor. So that will be our first project for today. So let's see how it looks in the software on the laptop. So for building the Wi-Fi scanner using ESP32, we are going to use Arduino IDE as mentioned earlier. And since we are going to use ESP32 board, make sure that you have selected that right board from the tools menu and select the ESP32 board along with the corresponding COM port. So right now since I have disconnected it, that's why it is showing disabled, but let me connect and the board and show you how it will look like. So once you connect your dev board, it should show the port over here, the COM3. Right now I am using COM3. So for you, for all of you, it may be something different. So depending on the port that you are using, you need to select. Just keep in mind that there can be possibility of multiple ports listed over here, and the one which you are using may be different. So just to know which port your board is connected, once you disconnect it, this will go away, or it may get disabled over here. And if there are multiple ports listed, so only the one which is connected will show over here. So now if I connect back, so you will see that it is now again listing here. So right now I am having only one, so it's no confusion for me. Also say if you are using this ESP32 board for the first time, you may not have ESP32 board listed over here. For that you need to go to board manager and install the respective boards and their corresponding libraries. So I will not go in details in this video on how to set up your ESP32 dev board on Arduino IDE. For that, you can watch my other video where I have covered this in detail. I can add a video description. In the description, I will add the link for that video so that it is easy for all of you. Otherwise, if you are already having then ESP32 board listed over here, select this and the corresponding COM port, and then you need to come to the code part. Over here we will be using similar structure, setup and loop. So in the setup we will add the details related to the Wi-Fi of the ESP. So since we are going to use, so we will update the baud rate that we are going to use. So we will be using this 115200, and then I've added a delay of 1 second, and then this Wi-Fi mode that we need to select is Wi-Fi underscore STA. So why disconnect is because if there is any data from the previous connections or anything, it will clear off and reset with the clean setup. Next is the loop. Here we'll be doing a Wi-Fi scan, actual scan, and then display the network details. So in this version, first version of the code, I will just plain simple give you a few syntax, a few code which we can run it to get the Wi-Fi details. So first of all is the scanning the network, the method to scan the network and store the returned value in a variable. So what we'll do is just run this Wi-Fi.scan networks, and this will return the total number of networks available, and it will store it in this integer variable. Now if the value of this is 0, which means that there are no networks, and if it is having some value, which means there are some network over here. So if there are 0 value, if the networks equal to 0 equals to 0, then which means that there is no network found. If there are some value, which means there are networks available in that after the scan. So next thing will be to loop through all the networks that are found. So if we find 10, 12, whatever networks we find, that will be the stored in the networks as an integer value, and we will scan through the values. So this will loop through from I is equal to 0 to the network less than total number of count of network, and then display the information. So what we'll do is we'll let me first show you the list of networks. So we'll display just so we will display the SSID of the network. So in this case, let me add a delay of say 10 seconds. Reason being, otherwise what will happen, it will loop through and then this for loop and display all the network SSID, and then again it will loop through this loop. So it will continuously run. So I am adding a delay of 10 seconds and then see. Let me compile and upload this code. So just one mistake. So we need to add this Wi-Fi library include file .h file. So that I missed over here. So do keep in mind the spelling of this Wi-Fi. The W is capital and then F is also capital, and since this is a case sensitive, you need to type in exactly as it is. So then this is the only library, the include file that we need to use in our code right now. So it is now uploading. compilation is successful. See, so if you see, it is showing 13 networks found and displaying the list of SSIDs, and next after 10 seconds it will again scan and then display. So what it is doing is, it is scanning the Wi-Fi networks around this place, and for this we are using ESP32. We are not using any other device, only ESP32. And after scanning, it will loop through all the networks that are scanned and then display the SSID. So this is what it is doing. So we can, along with this network SSID, we can display all the other information. Like if you see the second scan it has completed, right next it found 12 networks. So what we'll do, it will not only display SSID, but we'll do is we'll display few other Wi-Fi information like RSSI, which is the relative strength index, the channel number, that is what channel the router is using, and also the security, that is the encryption type that is used, and the MAC address. So all this information will display. Let me just add that part also in the code. So the RSSI, basically it is nothing but the relative index strength index, and then the channel number and the encryption type and the MAC address. We compile and then upload the code. So what it will do is display all this information one after another for each SSID. So right now in this version of code, I am not using any formatting or any display formatting, and straight away displaying it on the serial monitor one after another for all the SSID that it is scanning. So the upload is going on. Let me just move to the serial monitor. So if you see the result again, but this time instead of just the SSID, we are displaying RSSI, then the channel security, that is the encryption that it is used. It is right now displaying the default number in the numerical format. We'll use this and display it as in the human readable format, like whether it is the WPA or whatever encryption it is using, will display accordingly in the next version of the code. And then this number, this alpha characters that you see is of a MAC address. So you may try to think why we need this one, why we are trying to understand our neighbors RSSI and channel number. So the key thing here is the RSSI will give you the strength of the network that the Wi-Fi scanner is scanning. So the lower the value, like this one, -66 is having more strength than the -69. So if it is having 90 or above, -90 or above, it is weak or very weak. If it's 50 or less than 50, it is very strong, or very good or strong. Around 70 is an average. So if you see my network also, this 2.4 gigahertz network, this is -76. So this is relatively weak, or I'll say average strength, because I'm sitting at the extreme end of my corner of the house, where totally opposite to where the Wi-Fi devices router is set up. Similarly, for some of our neighbors, if you see, it is above 90, which are very far off from my place. So it -89 and so on. So this will give you what strength of network, Wi-Fi network, it is available at your place. Also the channel information, if you see the channel right now for me, this one, it is channel 9. So we will give you what channel you are using and what your neighbor is using, and you should try to avoid the channel that is used by most of the networks around your place, because this will cause congestion and reduce the Wi-Fi efficiency. So most of the routers, few latest routers do adapt to this and try to configure themselves the one which are relatively free. But if you have some of the older routers, you may need to manually configure it and see that you are not using the channels which your neighbors are also using. So in this display, in this you can see all the SSID are listed with all this information one after another, and it is not easy to analyze this data. So what we'll do in the next version, we'll modify this and display all the information in a tabular format, so that we can display so that we can see the SSID and the corresponding strength, the RSSI and the channel number, along with the security and the other information, though we will not be using that in our current project in any detail, but yes, we will display all this information in a tabular format. Also, what we are going to do is in the next version, since in this all the information I have just written within this one method, that is loop, we'll segregate and make it more modular, like the display part separately, printing the header in a tabular format in a separate method, and scanning separately, so that it is easy to understand and modify it later. So let me make that change and come back. So in this version now, I modified those that code and make it more structured. So the rest, the like this Wi-Fi.h is same. Then instead of hard coding the scan interval, we have made it as a defined using this configurable item. Then separate method for printing header, scanning the networks, printing the network info, and getting the encryption type. So this encryption type, if you notice that in the previous version of the code, the data that it was displaying was in a numerical format. So if you see, let me just show that code once again. So if you notice this output, this security, that security type, the type, it is showing in the numerical format. What we'll do is we'll convert this into a text that is more easily understandable, like whether it's a WPA or whether it's a open network and so on. So for that we are using this method, which will convert based on the number in the textual format. Next is the setup part. It is same, just that we have added some comments in the code. Next is the loop. So here the loop, we have removed everything from here and just added the separate methods, like scan network will scan the network and there will call the display header. So scan network, if you see, it will call this method. This is same, the scanning the network, Wi-Fi network, and storing the total number of network in the integer variable. Then this if condition is again same. If there are the value is 0, then there are no network found, else there are networks and it will display the total number of network that is found. Only thing is that I have not explicitly mentioned the else. If it is having 0, it is returning here and closing this method, this function. Otherwise, you can also in the as per the earlier version, you can remove this return and write everything else in the else part. So then it will print this header. This print header is written separately over here. If you see here, we are displaying all the data in different columns. The first column, it will display the serial number, that is sequence, then the SSID, then the RSSI, channel number that is used, security, and then the network ID, basically the MAC address. So once you print the header, then the next is the loop. This again loop is similar to the other earlier code. and within that loop we are scanning each and every network that was scanned and stored using the index value, and we are calling this print network info method by passing the index value as the parameter. So this, what it will do, this will display the actual all the information, network information that we want to display, showcase. So like the SSID, it is identifying the SSID and storing it in this string variable. Similarly, the RSSI, channel number, and all the details like the encryption type. So here again the encryption type, since it's an index value, for that particular index value it returns the number, whether it's 3, 4, 5, and what that number means in that as a textual format, whether it's a WPA or whether it's an open network. We are doing that analysis in this method. We'll see shortly. Then this is the MAC address, and all this we are displaying using the printf method. Then this the encryption type. So here it is, we are using the switch statement to get the value, textual equivalent of that number. So like if it is 1, then it is Wi-Fi auth as open, 0 is auth open, then this is a 1, so this will denote WEP. If it is 3, which means that WPA. If it is 4, which is basically 3 is WPA2, this is 2, so this is WPA, this is 1, which is WPE, WEP, and so on. So this, once we compile and upload this code, let's see the output, how it looks like. The only difference from the earlier version is that it is more structured and we have segregated the different parts of the code, so that if we want to enhance this later further, it is easy. And one more point that you noticed is the SSID, if it is empty, it will show as hidden. So right now in this current version, the first version of our scanner, we are not scanning any hidden SSID. So there is one SSID which I am using, which I have hidden it, which was not showing in the list of the SSIDs that the scan has result, and that's done. So in our next version, or maybe in the episode 3 or 4, we will try to scan hidden SSIDs also and show it along that. Right now this is just a placeholder. So in case there is a hidden no SSID with no text, like no name, then it will show as the hidden. So we'll run this, compile and upload this code and see the output. It may take few minutes, so I will pause the video for some time and then come back again once the upload starts. So the compilation is complete and it is now uploading the code. So let me open the serial monitor to display the output. So you can see the output, it is showing 13 networks found and relative strength along with SSID and the channel number that it is used. So key thing to note is that most of the neighbors, if you see the RSSI is above 90 or above 80. The one which is showing this is very next to our house, and the other one, the one which I am using, is 68 pin2_guest and this 76. So these are basically the average strength. It starts showing as good or very good because I'm at the very extreme corner of my house, where just opposite to where the router is placed. So it is around showing as average speed. Also the one which the 5 gigahertz network is not showing because that SSID I have hidden. So that hidden network is not showing over here in this list. So the next version, not the next, maybe in the episode 3rd or the 3rd version, I will try to implement the on showing the hidden SSIDs also. We'll see that later. but right now in this version it is not there. Also the channel number, if you see it, we can identify easily. There are many networks which are using 6, there are 4 which are using 6, so there are a lot of congestion with this channel. Ideally we should avoid using 6 because there are two, these two are same, I think same, from same household, these two are from same household. They are using channel 6 as the for their router, so there are possibility of congestion. I am using 9, which is, that is the one which is no one else is using, so 9 I am using. So 10 is also only one person using, 11 is also only one person using, 3 again is 3 persons are using, 3 networks are using channel 3, so there are a lot of possibility of some congestion. Then there is one channel number 1. So this information will give you what channel you should select, so with the avoid the one which is being used by most of the other routers from your neighbors. So in the current version of this scanner, we are displaying all the information on the serial monitor. So in the next episode, we'll see how we can display this in a display module and slowly convert this into a handheld device to scan the network. We'll add further features also, not just a display, but few features slowly upgrade and make it more professional looking project. This version is the very basic for a beginner, and so that it motivates you to wait for the next video, because this is very easy to set it up. We don't need we only need one hardware device, that is the ESP32 board, and nothing else. USB cable you will always be having at your home, and a laptop, that's it. So this project is very easy to build and get started to the next version of the project, where we slightly add into more complexities. Hope you have liked this project, and if you have any comments, any query, just let me know in the comments. I will try to answer as soon as possible. Thank you for watching this video, and hope you have liked this. And if you have watched till the end, do subscribe to my channel so that you get further update along similar videos, not only from this series but also from the other videos. And thank you again for being with me along with this video till this end.